Today we're starting section 11.2. We're going to be finding limits using some properties. So we're going to learn some properties that are going to act as shortcuts for our limits. So go ahead and find the sheet that I gave you to take notes on in class, and it should have this box on there, and you can use that to help you with your notes right now. The first one is the limit of a constant. So the limit as x approaches a of just a number c. Now, I'm going to show you an example and we'll work through it and you'll kind of see the connections here. An example of this would be the limit as x approaches maybe 4 of 7. Now, the thing you want to think about is what's the function here? The function here, let's look in terms of the c, is y equals c. Or in this case, the function is y equals 7. Now, that's just the equation of a horizontal line. So we're looking at a horizontal line. Now, no matter where I'm approaching, what x value I'm approaching, I'm never going to leave that horizontal line. It's always going to be on that c value. So the limit as x approaches a number of another number is just the c, the number. So the limit as x approaches 4 of 7 is just 7. Or the limit as x approaches 0 of negative 5 is just negative 5. So that's the first property. The second one we'll take a look at is the limit as x approaches a number of x. Now, when you think about this, this is just the function y equals x, and that's going to be a line. Now, as we're approaching any x value, the value on that function is that exact value. So the limit as x approaches any number a is just going to be the a. For example, the limit as x approaches 7 of x is just going to be 7. Or the limit as x approaches negative pi of x is just going to be negative pi. The sum and difference. The limit of a sum or the limit of a difference can be broken up into two limits and the sign stays the same. So for example, if I have the limit as x approaches negative 4 of x plus 9. This is a sum, x plus 9, so I'm going to break it up into two limits. I have the limit as x approaches negative 4 of x, plus the limit as x approaches negative 4 of 9. Now, using the properties we just learned, the limit as x approaches negative 4 of x is negative 4, and the limit as x approaches negative 4 of 9 is just 9, and negative 4 plus 9 is 5. And so the answer there is 5. If this was a minus instead in the middle, the only thing that would change is this would be a minus, and so would that, and then the answer would be negative 13. So that's the only difference if it's a difference. Moving ahead, the limit of a product. So now we're going to be multiplying. And if I'm multiplying two things, I'm taking the limit of two things being multiplied. Again, I can split it up into two separate limits. So let's look at the limit as x approaches 5 of negative 6x. I can rewrite this as the limit as x approaches 5 of negative 6 times the limit as x approaches 5 of x. The limit as x approaches 5 of negative 6 is just negative 6. The limit as x approaches 5 of x is 5, and negative 6 times 5 is negative 30. So now, I want you to pause your video, and I want you to try these two examples on your own, and then we can check them. Okay, if we talk through these a little bit, as you can see, hopefully you got negative 25 and 216. The first thing to be careful of is when you split this one up into a difference, you get 7x, which is now a product, so it gets split up one more time. The limit as x approaches negative 3 of 7 is 7 times. The limit as x approaches negative 3 of x is negative 3. And then we have the limit as x approaches negative 3 of 4 is 4. So we're going to do the multiplying and then the subtracting. Over here, 6x squared, this is actually a product of three things. 6 times x, because the x times x is what makes the x squared over here. Each of those limits equals 6, and 6 times 6 times 6 is 216. All right, go ahead now, flip that paper over, and we're going to fill in some more properties. The next one, the limit of a monomial. If we have the limit of c times x to an exponent, we can just plug the a in instead. So let's look at an example. The limit as x approaches 2 of negative 6x to the 4th. All we have to do is replace the x with the 2. So we're going to get negative 6 times 16, that's 2 to the 4th. And the answer there is negative 96. The limit of a polynomial. Now, notice that f of x has to be a polynomial. Remember, that's something written in the form x squared plus x plus more things, or x cubed plus 2x squared minus 3x. Those are examples of polynomials. When you're taking the limit of a polynomial, all you have to do is plug the a in for all the x's in your polynomial. Let's look at an example. The limit as x approaches 3 of 4x cubed plus 2x squared minus 6x plus 5. So now all we have to do is take that 3 and put it in place of all the x's. If I follow the order of operations correctly, I should get 113 as an answer. The power rule. If you're taking the limit of a function to an exponent, you can do the limit first and then the exponent second. So here's our example there. The limit as x approaches 2 of x squared plus 2x minus 3 to the 4th power. So really, I can redo the limit as x approaches 2 of x squared plus 2x minus 3. And when I'm done with that limit, I can take it to the 4th power. Now to find that limit, I'm going to use the limit of a polynomial property that says I can just plug the 2 in. So we're going to get 2 squared plus 2 times 2 minus 3. Turns into 4 plus 4 minus 3, which is 8, so it's 5. And then finally, that's going to be taken to the 4th power. So we have 5 to the 4th power, which is 625. The limit of a root works the same way. If you want to take the limit of a square root, you can do the limit first and then the square root second. So we have the limit as x approaches negative 2 of the square root of 4x squared plus 5. So I can do the limit first and then the square root second. To find the limit, I'm just going to plug the 2 in for the x. So we're going to get 4 times 2 squared plus 5. This is going to be 16 times 4. I'm sorry, it's a negative 2, isn't it, here? It's going to be 4 times 4, which is 16, and 16 plus 5 is 21. So we get the square root of 21 as the answer. final one is the limit of a quotient. Now, for the limit of a quotient, if you're dividing two things, you can do it as two separate limits, one on the top and one on the bottom. So, for example, the limit as x approaches 1 of x cubed minus 3x squared plus 7 all over 2x minus 5. I can just change this into two limits, one on the top and one on the bottom. Now to find each of those limits, I just have to plug those ones in. I'm out of room here, so let's see. We're going to get 1 cubed minus 3 times 1 squared plus 7. The same on the bottom, 2 times 1 minus 5. If I go ahead and solve that, I end up with 5 over 3. I'm going to give you one last example to look at, and I want you to try this one using what we just learned, and we will start with this tomorrow when you get to class.